If a machine can watch a simple instructional video the same way a person does, and then learn how to perform that task on its own, something profound changes. Learning is no longer limited to carefully written code or years of engineering for each new skill. Instead, the machine gains true flexibility, the ability to extend its capabilities endlessly. That idea, more than speed, strength, or flashy demonstrations, may be the most important statement ever made about humanoid robots. The question that truly matters is no longer how high a robot can jump or how fast it can move. Those achievements, while impressive, do not translate into real usefulness. Robots around the world can already perform acrobatics, fight, dance, and play sports. None of that answers whether a robot can walk into an ordinary home, understand what it sees, and help without being guided step by step. Homes are unpredictable. Kitchens are cluttered. Objects are misplaced. Lighting changes. Humans behave inconsistently. For decades, robots have thrived only in carefully controlled environments, like factories, where every variable is fixed and every movement is planned in advance. The moment something unexpected happens, those robots fail. This is why the idea of a humanoid robot that can learn from video, observe human behavior, make mistakes, and improve has shaken the entire robotics industry. Learning through observation mirrors how humans learn. And that shift represents a move from automation to adaptation. The next generation of humanoid robots is being designed with this philosophy at its core. The goal is not to build a machine that excels at a narrow set of pre-programmed tasks, but one that can handle thousands of useful activities across everyday life. The upcoming generation is expected to arrive soon, with capabilities ranging from cooking and cleaning to assisting people directly. The ambition is bold, a robot so natural in appearance and movement that it could be mistaken for a human at first glance, yet priced within reach of ordinary households. What makes this vision even more striking is that it does not stop with a single version. Plans already extend beyond the next release, with future generations designed for mass production at unprecedented scale. If one generation can reliably perform several thousand useful tasks, later versions could double that number, approaching human-level accuracy in many areas. This means the robot will not be limited to household chores alone. Hospitals, hotels, warehouses, offices, and care facilities are all potential environments where such a machine could operate daily. For years, bold promises have been made about the future of humanoid robots, not just to generate excitement, but to redefine what a technology company can be. The idea is to move beyond vehicles and into a future where intelligent machines assist with everyday life. The belief driving this effort is that a humanoid robot could eventually become more impactful than any other product the company has ever created. Cars are replaced every several years, but a robot assistant could work continuously, adapting and improving over time. One of the most striking claims about the upcoming model is its appearance. The design aims to conceal mechanical elements so effectively that joints, wires, and motors are barely noticeable. Movements are intended to be fluid, balanced, and natural, removing the stiff, mechanical feel that typically gives robots away. Subtle details from posture to hand motion are being refined to create something that feels familiar rather than alien. Behind this lifelike exterior lies one of the hardest engineering challenges ever attempted: the hands. Human hands are extraordinarily complex, capable of delicate precision and powerful grip at the same time. Replicating that functionality in a machine has defeated most robotics programs. Each hand in the new robot contains dozens of miniature motors working through a tendon-like cable system that mimics human anatomy. Fingers move smoothly, not rigidly, and fingertips are packed with sensors that detect pressure, temperature, and texture. This sensory feedback allows the robot to feel the difference between a hot pan and a cold glass, between a firm object and something fragile. It can adjust grip strength instantly, preventing crushed items or dropped tools.
Developing this level of dexterity has proven so difficult that the hands alone account for a large portion of the robot's cost and complexity. Yet without them, true usefulness would remain out of reach. Strength is easy, dexterity is not. This focus on hands reveals a deeper truth about real-world tasks. Everyday activities like cooking are not single actions, but long chains of decisions and movements. Preparing a meal requires identifying ingredients, choosing tools, adjusting grip, monitoring heat, and reacting to unexpected changes.
It demands coordination, perception, judgment, and timing. Hard-coding every step would be impossible. Instead, the robot learns by watching humans perform these tasks, breaking them down into patterns and sequences. The learning process does not happen only in the physical world. After observing a task, the robot practices it millions of times in simulation, refining movements, correcting errors, and improving efficiency. Only when performance reaches a high level of reliability does it attempt the task in reality. This approach allows rapid learning without constant risk or damage. It also means that once one robot masters a skill, that knowledge can be shared instantly with every other robot in the network. This shared learning system transforms each individual robot into part of a collective intelligence. When one learns how to fold a shirt neatly or prepare a specific meal, all others gain that ability almost immediately. Improvement no longer depends on manual updates or individual training. The entire ecosystem evolves together, accelerating progress at a pace never before seen in robotics. Household chores are a natural starting point for building trust. Cleaning, organizing, and basic food preparation may seem mundane, but they are the tasks that demonstrate reliability and safety. A robot that can vacuum intelligently, avoiding small objects and adjusting suction based on debris, proves it can perceive and reason. When it wipes a spill carefully, rinses a cloth, and finishes the job neatly, it shows awareness and control. These small successes matter more than dramatic demonstrations. Balance and recovery are equally critical. A robot operating around people cannot afford to fall. Even a single stumble could pose a safety risk. Subtle movements, such as adjusting posture or taking a quick corrective step, reveal the system's ability to predict and prevent failure. This constant self-monitoring mirrors the principles used in advanced vehicle autonomy, where systems are always scanning for hazards and adjusting in real time. The intelligence behind the robot is not separate from other technologies. A unified perception and decision-making model allows experience gathered in one domain to benefit another. Visual understanding, motion prediction, and response to unexpected events all contribute to a shared understanding of the real world. As robots are deployed more widely, they generate even more data, creating a powerful feedback loop that drives continuous improvement. One of the most immediate and meaningful applications for such a robot is in care for the elderly. Many societies face a growing aging population alongside a shortage of caregivers. A humanoid assistant could help bridge that gap by supporting daily activities, reminding people to take medication, assisting with movement, and detecting hazards. It would not replace human relationships, but it could enhance safety, independence, and quality of life. The same applies to families with children. A robot assistant could help with homework, read stories, and maintain routines without fatigue or frustration. Parents could monitor interactions and maintain control, using the robot as a tool rather than a replacement. Its value lies in consistency and availability, not authority or emotion. Fears about robots replacing humans or becoming dangerous are deeply rooted in fiction. In reality, today's machines operate within strict constraints. They do not set their own goals or possess desires. They perform tasks defined by humans using tools designed and monitored by people. Automation has always changed the nature of work, but it has also created new opportunities. Robots are most effective when they take on repetitive, exhausting, or dangerous tasks, allowing humans to focus on creativity, empathy, and leadership. Even as technology advances, cost remains a limiting factor.
A humanoid robot priced similarly to a vehicle will not instantly replace human labor across the economy. Adoption will be gradual, shaped by practical value rather than hype. The real challenge is not competition between humans and machines, but collaboration. Learning how to integrate intelligent robots into daily life responsibly will define the next era of technology. The vision driving this effort is ambitious, and skepticism is natural. Announcing future generations before the current one is released raises questions about strategy and expectation. Is it a sign of confidence, or simply a way to keep attention focused on what comes next? Regardless, the direction is clear. The focus is shifting from spectacle to usefulness, from isolated machines to shared intelligence, and from rigid automation to adaptive learning. If that vision succeeds, the impact will extend far beyond any single product, reshaping how humans interact with technology in their everyday lives.